Hello, I'm Helen Arney.
I'm Steve Mould.
I'm Matt Parker, and this is a podcast of unnecessary detail.
Yes, if you are here for the podcast, that is great. But if you're here for the detail, that's even better.
This time, we are talking tables.
Literally, I'm talking about times tables.
Yeah, I'm taking on the periodic table.
And I've got a finite dog table.
A dog table.
A finite dog table. And it's exactly what you think it is.
Yeah, I have no idea what I think that is. So let's find out. Matt, what is on your table?
I have a fun fact I saw online that in the US, you're not allowed to have more than 37 dogs that all have the same name.
You're not allowed to...
Yeah. So you can name 37 dogs like,
Steve,
hypothetically Steve, yes. But if you go to name your 38th dog Steve, you're not allowed to.
But you don't have to own all these dogs yourself, right?
Anyone.
Some kind of catalogue. A table of dogs.
A table of dogs.
So hold on, there are only 37 dogs called Rex in America.
That's the claim, and it's pretty much true. So I decided to dig into this. It's the American Kennel Club who are in charge of keeping the massive table of all the dogs that are of different breeds. And they have the ruling that they will not allow more than 37 people to all name their dog of the same breed the same name.
Oh.
So this is by breed. So if you've got a boxer or, Labrador, and you go, I want to name my Labrador Steve, and they're like, I'm very sorry. There are 37 other people in the United States who have all registered a Labrador with us, all named Steve, and you're the 38th, which we don't allow.
But if they want to register, they have to pay money. So theoretically, there are more dogs called Steve out there, but they're not registered.
That's very true.
This organisation.
It's not against the law. So if you name your dog Steve, you're not going to get a knock on the door. It's the police. 37 people already named their dog Steve. You're in trouble.
Can I just say, Steve is not a dog's name. I just got to make that clear.
You suggested it as an example, so that's what we're running with. So what it turns out is this kennel club who are like, we're in charge of the dog names. Just everyone register your dog with us. And it does cost $25 a go to register your dog. So you got to be serious.
Oh, I wouldn't bother registering a dog called Steve for $25. It would be Princess Steve at the very least.
Well, this is part of it, right? Because if you have a more complicated name, you're fine, because if no one else has it. But if two people wanted to register, let's say, a golden retriever named Steve.
That's my spirit animal.
Exactly. I looked at you and just golden retriever came to mind. When they go in the database, the American Kennel Club are like, how are we going to tell these apart? And so they give all the dogs which are the same breed and the same name a number. And they write that number down in Roman numerals. And when they're putting it into, index cards or however they used to do this, they only had 6 spaces for the Roman numerals for the dog number. And if you start counting from 1 and you go up sequentially, the biggest number you can get to in Roman numerals in 6 spaces is 37. If you want 38, you need a 7th place.
So this whole rule is because of the way they set up their database, the way they logged dogs on a table in the first place.
How did I know that your table will be a spreadsheet?
Everything's a spreadsheet. And what I love is they've picked one of the least efficient ways of writing down the numbers. If they just use normal digits, 6 digits, you're going to get up to 1 million.
I think there's something about dog breeders and dog owners is that they also come in lineages, so lots of dogs do have the same name because it shows that their pedigree has come from a certain dog, right? So there are loads of dogs that are Bootsy Van Rudolph V, and that's a dog breeding thing, right? And they want to make sure they're all different and that their prize-winning dog doesn't have its name stolen by someone else.
Exactly. And I guess it sounds more regal or something to use Roman numerals. Yeah. But this led me down the rabbit hole of what happens if you use Roman numerals as a form of data storage? Because it's not efficient. It's not like a positional counting system where we have a units column, a tens column, a hundreds column, and so on.
That's what we've got now, is it?
Normal, yeah, normal. So if you see 37 written down, you go, that's 3 tens, 7 units. Whereas in Roman numerals, an I is always 1. A V is always 5, X is always 10, C is always 100, and so on. And the only variation you get in Roman numerals is if you put them out of order, they become negative. So if you wanted to write 6, you'd write V and then I, so that they're descending down. So you add them. That's a 5 and a 1 is 6. But if you want to write down, let's say 9, you'd put an I first, then an X. So now the small one's first where it shouldn't be, becomes a negative 1. So 1 off the X, which is 10, that gives you 9. So it's this weird system where every character always has the same absolute value, but it's positive or negative depending on if it's in sequence or not. That's not the traditional way of describing it. That's how I understand it. If you're allowed gaps, there are actually 1,308 distinct numbers which fit in 6 or fewer characters.
Right.
But they want to go in order for some reason. And when they hit 38, so for 30, that's XXX. And then for 8 is, also going to be 5, 6, 7, 8. V, I, and that's 7 characters. If you allow yourself 7 characters, then you run out of space at 87. That's the biggest number you can have.
Okay, 87, Steve.
87, yep.
Right.
If you're allowed 8 characters, you run out at 187.
Okay.
If you've got 9 characters, it's 287. There's a pattern here.
What?
10 characters, 387. 11 characters, 887. It's always the 8s. It's 8s. That's the problem.
Because they're long, because it's VIII.
Yeah.
So that's like a really long string.
I was a bit annoyed that they don't, because you could have more than one in a negative position. So 8, instead of being VIII, could just be IIX for take 2 off 10.
Ooh.
But that's not how
That's
it
not
works.
how Romans did it, or that's not what the rules are.
You're suggesting an overhaul of the Roman numeral system,
There are several ways I'd overhaul
which
it.
seems really relevant to today's society.
If you just, well, hey, it's a problem here. If you just allowed more than one character to be negative, that's the same. You could count up to 132 using just 6 characters in Roman numerals in sequence starting at 1. But apparently, no. Okay, you know what? I'm bringing up the database. We're going to see if we can find
you can
a
actually look.
Steve.
You can search the American Kennel. What is it? The American
The
Kennel.
American Kennel Club.
AmericanKennelClub.org.
I'm on their dog search system.
Oh.
So, should we look up a Steve?
Yeah.
Steve. Oh, Steve, what breed are you? Are you a golden retriever?
I am a golden retriever.
Okay,
yes.
done. So,
What's the betting that there are 37 Steves already?
Oh, there's bound to be.
there are not 37 golden retriever Steves. There are 10.
Wow.
So if you wanted to join this list, Steve, you'd have to be Steve XI.
Classy.
Hold on a second. Is that in perpetuity? So what if a Steve dies?
It just says they permit 37 dogs of each breed to have the same name. It then says name choices are limited to 50 characters. And that's interesting because that's another limit. Because if the number is limited to 6 characters, we're like, oh, it runs out at 37. When will the names run out? Because they're limited to 50 characters. In fact, you have to pay more if you go over 36. So you're allowed
How much do you have to pay?
a $10 fee if you want more than 36 characters. I don't know. Maybe they got to stick 2 cards together. I have no idea what kind of a system they're running.
It's a money grab, isn't it?
It
It's
really
a gouge.
is.
These people are unbelievable.
Pedigree premium, surely, because all
Pedigree
the pedigree
premium.
dogs have really, really long names.
They
There's a
do.
correlation between wealth of owner and length of dog name.
Oh, that would be a good graph.
So I have checked all the conditions. You're only allowed the standard English alphabet. It's in America. You're allowed spaces, apostrophes, and dashes, like a hyphen, but they all count towards your 50 character limit. And you don't get upper or lowercase. You don't get like umlauts or any interesting characters. And there are a few restrictions. So you're not allowed to put in something that's used in a dog show. So you can't call your dog Champion Steve.
Right. Or Best in Show.
Or Best in Show Steve. Exactly. Oh, you're not allowed any obscenities or words that are derogatory towards any race, creed, or nationality. There you are, nothing offensive. You're not allowed any kind of breeding names. You can't put in male, stud, bitch. I mean, okay, there's 2 reasons why you're not allowed that word. Damn, I wonder what that means. Anyway. So you're not allowed those words. You're not allowed to just call it a breed name. So you can't have golden retriever, the golden retriever, as self-referentially pleasing as that would be. And you are allowed normal numbers. So 0 through 9. So actually, you could be Steve 2000, the third.
Look it up. Is there a Steve 2000?
Is there a
Come
Steve?
on.
Okay, hang on. Is there a Steve,
Steve 2000?
Error. We are sorry, but we were unable to locate your dog for one or more of the following reasons.
Oh.
Okay, so I actually double checked. If you can have 39 different characters in 50 spaces, the total number of possibilities of all names for dogs is about 3.6 times 10 to the 79, which is a big number.
That's 36 with 78 zeros after it.
Correct.
That's like an astronomically big number.
That's nearing or might be bigger than the number of atoms in the observable universe. It's within the range of estimates of how many atoms there are. It's either a bigger number or it's slightly smaller. Physicists argue about this, but it's on that kind of size. So what that means is, while the 6 digits you get for the Roman numerals for the number of your dog cap out at a value of 37, the 50 characters allowed for the name has enough possibilities that you could name everything in the observable universe. Everything could have a name, and it would still fit in the American Kennel Club database. I love the fact that they've woefully underpowered one data bit, and then the other one's way bigger than... I mean, most of those won't make sense, but that's crazy.
Hi, it's Helen here. Now, this isn't an advert break. Well, sort of, not really. It's more of a buddy break where we take 60 seconds of our Unnecessary Detail podcast to tell you about some of our favourite other podcasts. And I've used up 10 seconds already, so I'm going to have to do this quickly. Go. Number 1 is Worst Foot Forward, the podcast that celebrates the world's worst everything. Worst scientist to worst board game, worst vending machine, worst element. Now, I was in that episode and it's astatine. It's an element so daft it destroys itself when too much of it is in one place. Number 2. My Mate Bought a Toaster. This is where Tom Price gets to know way too much about comedians by looking at their Amazon purchase history. Uh-oh. Number 3 is Drunk Women Solving Crime. It does exactly what it says in the title. 3 comedians and a guest get drunk and solve crimes. Number 4 is Scummy Mummies. That's my local podcast where 2 South East London comedians put the world to rights for everyone who has had, will have, or just knows any children. Wine is often involved. Number 5 is comedian and all-round brilliant human Jess Foster-Q, who chats food and so much more in her amazing podcast, Hoovering. Okay, that's done. That's all 5. Now rewind for 60 seconds, write them all down and look them up in iTunes, Spotify, or wherever you find your podcast. Thanks. Back to the detail.
I want to talk about times tables. I hate times tables.
Oh, wow. This is a table of hate.
It is.
You hate times tables. You hate multiplication.
No, it's not that. Okay, so what it is, and it's interesting. I mean, maybe that's not controversial to say I hate times tables. Probably a lot of people didn't enjoy doing times tables at school.
I don't think people are passionate about it.
Yeah, and maybe even if you don't like times tables, you might think, well, yeah, no, but they are important and you should be doing them. I would argue that that's not the case.
Whoa.
Wow.
Yeah. So times tables is a memory exercise that you do at school where you memorize the answers to a whole lot of multiplication questions, and it's basically all the numbers up to 12. So 2 2s are 4.
1 7 is 7. 2 7s are 14. 3 7s are 21. Yeah. We've all done
You're
that.
not saying actual numbers there, Steve, so I think I've isolated your problem.
Oh.
But also, so in Australia, this was an early form of like
Torture.
public humiliation. I remember we had to go up the front of the class and we'd be quizzed on these things, and there was all sorts of ways to, use peer pressure to make sure you learn your times tables.
That's so interesting because my 2 older sisters used to learn their timetables, and I went to a different primary school from them, and mine was more progressive, and you didn't have to learn their times tables, which is maybe why I am less bothered about times tables in a way that you are.
Man, I didn't like them, but I'm not discussing banning them as an adult on a podcast.
Okay, so full disclosure, I'm dyslexic, so that may tarnish my opinion.
I think it makes you uniquely qualified.
Yeah, okay, that's where I like to look at it. So dyslexia, there's maybe misconceptions about it. It's dyslexia is kind of a description of a set of symptoms more than anything else. So it's not like a diagnosis, like if you've got a viral infection, for example, you've got this particular virus and these are the symptoms.
You don't catch dyslexia.
Yeah, but also it's not like necessarily a specific genetic disease either. It's like these are your symptoms. If you have these symptoms, then we say you're dyslexic.
From whatever cause.
From whatever cause. An educational psychologist once described it as if you've got a spiky profile.
What?
So
like you've got a big nose?
Hey.
Or you...
Just because Steve's still got hair.
Oh, Matt, you have such a smooth
I have
profile.
a very smooth profile.
No, so basically, if you do a whole suite of tests. You test your reading comprehension, reading speed, spelling, mathematics, problem solving, logic and reasoning, all these sorts of different tests. And, a normal person might have just average marks on all those, or quite level, right? Either all really high or really low, or, somewhere in between.
Consistent, yeah.
A spiky profile is when maybe you're high in lots of them, but super low in one or two.
Oh.
So it's spiking downwards, I suppose.
Oh, that's a better definition of dyslexia because it's not just about, for instance, not being able to read the word dyslexia, which is the
That's
classic.
ironic. Yeah. Here's the thing. The way I'm dyslexic, one of the symptoms is I'm really bad at memorizing things by rote. So I can learn things if there's a logic to it or a reason to it. But, and here's the thing. My brain is so bad at that particular skill, learning by rote, that it didn't even occur to me that that's what people were doing with the times tables. Like, that's what you're supposed to do. You're just supposed to know it by memory.
You didn't even realize there was the feature where you just store data randomly and then recall it.
Absolutely not.
And at some point in the future, you go,
What was that thing I remembered? Yeah.
5 8s are 40. You just remember it.
That's not what I thought was happening.
What were you doing?
I was getting really good at working it out quickly in my head. And actually, I got pretty good at it. At the time, I didn't think I was very good because everyone else was still really much quicker than me.
Because they were recalling it.
Yeah, and I didn't know they were doing that. And it was only when I figured that out, like when I worked out that's what was going on. Oh, you're supposed to memorize it, and that's what other people are doing. It was an amazing relief to me. But here's the thing. Here's why I think they're bad. Certainly for me, and I think possibly for other people as well, is that if you tell people, look, this is the first thing you're going to do in mathematics, or one of the first things you're going to do in mathematics is memorize this list of things. You're telling people this is what mathematics is. And by the way, it's super boring.
Yeah, it's super boring. Yeah.
I can't argue with that.
And people who are good at that will go, oh, great, I'm good at maths. And then later on, they might struggle when actual problem solving comes into it. And so you get this disparity of, initial skill or whatever. But whereas the way I was doing it, I learned all these tricks and I was looking for patterns and solving puzzles and stuff like that. And that kind of developed that part of my brain. And I really enjoyed that, actually, like finding little tricks and stuff. Like, for example, if you want to multiply something by 8, you just double it 3 times.
Which is insightful.
It's insightful. It tells you something about the structure of numbers and the nature of multiplication and that sort of
So if I said 6 7s.
6 7s, well, okay, so that's a tricky one. 6 is difficult. Normally what I would do is triple it and then double it.
Oh, okay.
Because tripling isn't so hard.
Well, because I'm somewhere between you, because I hated times tables as a student because I was terrible at just memorizing them. And don't get me wrong, I do memorize ridiculous things for the sake of it. Let's not pull on that thread. However, when I was at school, I was like one of the worst students in the class for doing times tables. But I would do a mishmash of memorizing some and using patterns for other ones. So 6, I would just double the 3 times table. So to this day, I would have to go, double 21 to give me 42 to be able to do that.
Oh, because that's weird because I'm doing it differently.
What are you
doing? When you say 6 times 7, I'm doing 5 times 7 plus another 7.
Oh, that's nice. So if you want to multiply a 2-digit number by 11, for example, then you end up with a 3-digit number. You put the first digit at the front in the hundreds column, the last digit at the end in the units column, and then you add the 2 numbers together and you put that in the middle. Again, that's a kind of obscuring what's going on. But so when I was doing 11 in my head at school, I would just multiply by 10 and then add one lot.
That 11 one works easily for things like 24 would be 264.
Yeah.
But if it's too big, if it's like 68, you've got a rollover.
You do.
So now it's 748.
Yeah, you have.
But still, it works. It's quicker. I think I was partially. That's why I was bad at multiplication. I was partially doing the Steve technique.
Yeah.
I'd memorize some, And then I was way more excited about finding the patterns and doing it that way, which is slow.
So the sad thing for me is like, I thought I was bad at maths. And, because I wasn't as good as other people at my times tables. And it was only when I worked out what was going on that I thought like, actually, yeah, I enjoy this. I enjoy the process of finding patterns and stuff, which, later on I discovered actually that's what mathematics is about finding patterns and solving puzzles. And you could argue that memorizing times tables is probably the best thing for the average student, and I'm not the average student, which is why it didn't work for me. But I would argue that if you present memorization of times tables to kids and say this is mathematics, then that's a real problem.
Okay, here's an argument for times tables.
Oh, this is where things are going to get testy now.
It's not going to be easy.
Steve versus Matt.
And this is coming from a place of someone who didn't enjoy it. It's removing a barrier to entry for other mathematics, because there's so many things in maths when you're a student where being able to multiply quickly and easily means you can do more interesting maths problems and maths working out. Whereas a lot of students come unstuck with the fiddly, pointless multiplication. I would now argue that we've got calculators, so actually that argument's a bit more null and void than it might have once been. But also at the time, back in the day, that's a very good life skill to be able to do quick mental arithmetic to multiply. And the quickest way of doing it is rote learning, which the average student is fine with. But I think it was just trying to get students so they're more comfortable and fluent with some basic mathematical operations, so that they're not bogged down doing later maths and rote learning times table. That just solves so many problems later on. But you're right. Maths can very easily be very boring.
I suppose the point is maybe do both, because let's call it the mold method.
Wow.
No, come on. I don't know why you're laughing. It's a really good idea.
It's called the Steve technique.
The Steve technique is it works beyond 12. So you memorize the times table up to 12, and if all you're doing is memorizing, then that's all you've got.
Oh, then you get really stuffed at 13, 14, 25.
You've got no coping strategies after 12.
Yeah. I remember learning the 25 times table. I'm not so good at it nowadays, but I learned it because it was our family tradition when you get home from school to watch Countdown. And if your vocabulary is not very good, then the numbers round is where you can really excel.
It's your time to shine.
And then a couple of years after I left university, I don't know if you know this about me, I auditioned to replace Carol Vorderman on Countdown.
Oh.
Yeah.
You wanted to be the new Carol Vorderman?
Yeah, they did the star search for the new Carol Vorderman. That ended up giving the job to Rachel Riley, of course.
Of course.
Fantastic, wonderful. She's brilliant. But I got down apparently to the last 10 people.
Wow.
No, I was so close. And that was because I spent my entire childhood training myself on the 25, 75 times table, being able to do these conundrums.
For our non-British listeners, what is Countdown?
It is a television show that is on in the afternoon. It's a very gentle British kind of quiz show where two people compete to solve anagrams with letters and a number problem where they're given a bunch of numbers and they have to reach a target.
It's not just someone counting down.
No.
Make that very clear. It's for anagram and number fans.
Exactly. And it's a delightful, inoffensive afternoon treat.
Okay, so I think there might be a point here where memorizing in maths is fine if it's for a reason. This podcast is sponsored by Brilliant.org, a website dedicated to promoting a culture of learning based on inquiry, curiosity, and openness to failure. That's one of their founding principles, which I personally think is fantastic. So if you haven't come across Brilliant.org before, they've got loads of puzzles, and they've got daily puzzles. I love the maths ones, do them all the time. That aside, they've also got loads of courses you can do. So if you've ever thought, you know what, I have not learnt enough maths and science and, engineering, this is a great way to get started. Or if you're like me and you have done a maths degree, but my goodness, it was a while ago, it's a fantastic place to do courses and brush up. So yeah, they've got other ones on things like quantum computing and relativity and neural networks. They're all the rage. For me, I enjoy mathematical fundamentals. These are the essential tools for mastering things like algebra and logic and number theory. I think amazing things which are all the more enjoyable when you're studying them because you want to learn them, not because you've got to get through a degree or school or something else. So I highly recommend checking out brilliant.org APOUD. Because as well as being an amazing company who want to increase access and inspire people when it comes to these STEM, science, technology, engineering, maths subjects, they also sponsor this podcast. So I think they're incredible folks over there who run brilliant.org. And if you go to brilliant.org/APOUD, not only are you supporting this podcast and the company who sponsors it and makes it possible, but you will also get 20% off an annual subscription. So that means 1 in every 5 things you learn will be completely free. There you are, brilliant.org/APOUD.
So we all know how Steve feels about that kind of table, but I want to talk about a table that I absolutely love, and so do many other people, not just me. I have a thing about the periodic table. Yeah.
Oh, yeah.
Yeah, I know.
Well known, well documented.
Exactly. I own a load of stuff with periodic tables on. I've got a dress, a skirt. They're all completely non-iron, by the way, apart from a little tiny square.
Of iron.
And the pinnacle of my periodic table collection is the fact that I have learnt the periodic table in the form of Tom Lehrer's Elements song, right? Which is the very famous song set to a tune by Gilbert and Sullivan, or Sullivan. This is a podcast of unnecessary detail. You need to know that it was Sullivan, not Gilbert and Sullivan, who wrote the tune. And Tom Lehrer, this Harvard mathematician, came up with a song that has 102 elements of the periodic table. Not in periodic table order, I hasten to add, but in rhyming order.
That's worse than the times tables. At least the times tables had a point.
You just memorize them in some arbitrary order that someone at Harvard came up with.
Yeah. But it's the most joyful thing to sing. And this song is now lodged permanently in my memory. And I've actually finished it off because I said 102 elements. In the original song, I've added the 16 that were discovered since then. And I think at the end of this podcast, we've got a recording of me singing the whole thing, so you can use that to learn it and
Were
enjoy
you the
it
first
yourself.
person to put in all the new ones?
That I know of, yeah. Channel 4 commissioned me to write a final verse with all the final 16 in, because it was the day that they officially announced the new names, and that was back in 2016.
And you're on the news.
Yeah, I was on the
singing
news.
the new elements. Does that mean you got to decide the new arbitrary but slightly rhyming order?
Yes.
That's
and I've
amazing.
changed it since then, because the order I did that day wasn't as good as the...
Suboptimal.
Yeah, I've improved it.
Is it because you're thinking about how it's going to scan, how many syllables and all that sort of thing?
Yeah, also because one of the new 4 elements, the ones that people listening might not be familiar with unless you're an element fan like me, they're Moscovium, Nihonium, Oganesson and Tennessine. So 3 of them are named after places: Moscow, Japan, Nihon, Tennessine, and Oganesson, which is named after Yuri Oganessian, who discovered many of these super heavy elements, right? He's one of the only people who's ever had an element named after him while he's still alive.
Wow.
Yeah, only 2 people have had that honor, the other being Glenn Seaborg. And the reason I've changed it is when I do it live, quite often I get a massive cheer on Tennessine, because there's Americans in the audience.
Yeah, they're going to hoop and a holler.
You have to pause for them chanting USA.
It takes a while.
USA. That died down.
And when we did this song in Alabama, we went to do some shows in Alabama. Tennessee's next door, but they still gave it as big a cheer as if I'd said Alabama. Yeah. But there is a better version of the Elements song that kids know.
What?
ASAP Science on YouTube, brilliant channel, have done a version where all of the elements are sung in periodic table order.
Ah, that's better.
Oh, that's good.
It goes something like hydrogen and helium and lithium, beryllium, boron, carbon, blah, 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 nitrogen, blah, blah, blah. You get the idea, right? It's useful.
Yeah.
It's like the equivalent of learning the
times tables.
I did memorize all the atomic weights in order.
Shut up, you stupid idiot.
But
it's just the numbers. It's the numbers for anyone who's wondering. I just learnt the numbers in order. I was going to say, when you're talking about memorizing things in an arbitrary order, on my list of pointless things to learn is the first 100 numbers in alphabetical order.
Oh my God.
Wouldn't that be great? Wouldn't it be amazing to say you can count to 100 in alphabetical order?
How would that start? What would it look like?
It starts, I've got a list here. It starts 8. That's the first one.
Okay. 8.
It's just the first 100. 18, 80, 88. And any guesses for the last one? Second last one is 2. The last one is 0. Thank you very much.
I wouldn't have
first 100.
I wouldn't have counted.
I did 0 to 99.
That's
It's my arbitrary order. I choose the rules.
That is absolutely horrific. So there's all these names of elements, but there's also names of elements that never got used because they were ludicrous jokes by physicists.
So it's like if you were trying to name a ship.
Yeah.
And you opened it up to the internet. There'd be loads of attempted names.
It's not quite like that. It's like loads of people have made ships.
And they realise it's the same ship.
Yeah, they've all given it different names. And
only one name can
win.
Thank God there isn't an element McElementy face.
So on the periodic table, only elements below number 92, uranium, are naturally occurring. Everything else has to be either synthesized in a laboratory or discovered in the aftermath of an atomic bomb.
In this case, you're defining naturally occurring as blown out of a supernova.
On Earth already, yeah.
All right, okay, yeah. So the energy required to make it happens at some point, or there's some process by which it's manufactured in our universe.
And it's stable enough that it has already completely decayed.
It's landed on the Earth, and a chemist has picked it up and gone, hey, look at this.
Yeah, check it out. Yeah. Oh, and then realised it's uranium. Gone, I think I'll put that down.
Oh, I'm dead.
Yeah. So 1960s, Russia had discovered loads of elements. America had discovered loads of elements. They had discovered the same elements.
They weren't talking much then, were they?
Yeah, they were not chatting.
And probably their research into nuclear physics was not top of their share list.
Oh, no. Yeah, because a lot of this was offshoots of the nuclear weapons programs. And that's where a lot of these elements were found. There's one element that they proposed to be called Los Allium, which is element 99, which was later named Einsteinium, after the Los Alamos
research place,
nuclear research facility in the
still
US.
There, still
right?
down.
So all of these elements were being discovered, but between the 1960s and 1990s, Russia used one set of names for these new elements. America used another set of names.
That's going to cause problems.
The Europeans were like doing their own thing as well.
Wow.
They don't even count in this story.
I want to use some of these old names.
Yeah. So the American names for elements 101 to 106, Mendelevium, after Dmitry Mendeleev. Yeah, it's great. Nobelium, I guess after like
Nobel.
Lawrencium, which is after Lawrence.
Yeah.
Rutherfordium, after the Manchester physicist who discovered the structure of the atom.
Yeah,
right? Hahnium, after Otto Hahn. We'll get back to him later. And Seaborgium, who's Glenn Seaborg, who's the only living person who's at the time who had an element named after them. The Russians also wanted Rutherfordium, but they were using it for a different element. So the Americans used it for 104. The Russians used it for 103. You see what a mess this is. So the independent council came in, right? The International Union of Pure and Applied Chemistry, who is still around now today, and together with the International Union of Pure and Applied Physics, decide the new element names. Oh, that is a council and a half.
That's a council of councils.
Yeah, this is really amazing.
That's a council.
They, between 1992 and 1997, suggested that Rutherfordium be used for element 106, which is a completely different one. So the Americans were like, what about 104? Russians were like, we're using it for 103. And this
no one
organisation
gets
said,
their one.
No, you're not having it. What about 106? It ended up being 104 for various reasons.
Was that one that sounded like Helenanium or something?
Oh, Hahnium. Yeah, that was a good one. That's Otto Hahn, who co-discovered, I should point out, nuclear fission. So,
I bet you're gutted about that.
Yeah. Well, because that element never got used.
Yeah.
Hahnium, which is like you guys'
Your
nickname
element.
for me.
Yeah, Arnie. We haven't got time for Helen and Arnie.
Arnie. That is the element that, if it existed, it would be my name. I would have had HA. Problem is, Hahnium eventually was given the name Meitnerium after Lisa Meitner, who was Otto Hahn's co-discoverer of nuclear fission, along with someone else as well, right? So Lisa Meitner, Otto Hahn, and this other Otto guy, they discovered nuclear fission between them. Who got a Nobel Prize?
Not the woman.
Yeah.
The correct answer is always not the woman.
She didn't get the Nobel Prize.
No prize.
She did not share the Nobel Prize where the other two did.
Wow.
Right? What? But
what a jerk move.
Here's the thing. The next element to be discovered is going to be really, really hard to discover. And there are groups in Japan, there are groups in Russia, there's teams in Germany. They're working with scientists in the United States to find element 119. Millions and millions of pounds.
Is that its working title?
Yeah, it's called element 119. Or if you use the standard systematic naming convention, ununenium.
Well, slower.
Ununenium.
Ununenium. So there's like an old system where, like, if it's element 101, it's un, and then 0, which is nil, and then unium, which means 1. So
101.
Unilunium.
And this one's
101.
This is whatever Unununu language is for 119.
Yeah, so it's so like
Literally
something like
119.
106 would be unil hexium. So like hex is 6, right? We all know that. So un, which means 11, and then enium, which stands for 9. So ununenium. And my favourite one's 111, which was called for a while unununium.
It wasn't.
Unununium.
It's ridiculous.
It's so good. Right. So 119 is going to be really, really hard to discover, partly because in order to prove that you've discovered an element, you actually have to show that you have made it, not what they do at CERN, which is when they found the Higgs boson, just show that a Higgs boson decayed into something that you've seen.
Physicists.
Right.
We probably had one.
Yeah.
It left some of its stuff behind.
The likelihood of it being that is very high.
Yeah. Do you want to see all our sigmas?
Yeah, exactly right.
We got 5 of them. We got 6 of them.
Can't do that with...
You got to actually have the element.
You got to have it, even for a fraction of a second, right? So this is going to be really hard to create element 119. Mostly because the detectors they have are not able to detect it quickly enough before it decays into something else, because it's super radioactive, it's super unstable, it's got like hundreds of protons and neutrons in the center, it's incredibly heavy, it's just absolutely ludicrous. They're throwing massively radioactive particles at other really reactive particles in the hope that some chunk might fall off that is this element 119. It's absolutely ludicrous. But when it comes to being named, because of the transuranic debacle, where they had to rename everything because the Russians, the Americans weren't talking, there is already a committee set up ready to name that 119. It's already there. The first dibs goes to the discoverers. If they can't agree, then the committee gets to name it. So my mission now is to get onto that committee.
On that committee.
Yeah.
And Harnium could
It's
ride
back
again.
on the table. Does Harnium rhyme well? Is like a good rhyming word?
Yeah, I think Harnium could definitely get in there. Oh, there's one major problem though. Once an element name has been adopted and used, even if it's not officially confirmed, you can't use it again.
No.
So, there'll be no Harnium again.
Oh.
No.
Oh, there you go.
Harnessine?
Harnessine.
Harnon.
Hanon.
I'm going to have to wait till they discover another noble gas.
119 would be Hanon.
Yeah, no, it won't be. It won't be Hanon because only the noble gases get to be Hanon.
So you got to wait.
So it'll be like plus 18. It'll be 127 or something.
You got a while.
Oh, mate. Oh, they better get on with it.
All right, that's all we have tabled for this episode. Thanks for listening, and thanks to our sponsor, brilliant.org. You should go there.
We also have a whole metric heap of extra show notes and links over at festivalofthespokennerd.com/podcast, which, fun fact, is approximately 2.2 imperial heaps of links and extra show notes.
Yeah, we've included those Kennel Club rules in full that Matt mentioned. There's a link to the new ASAP Science periodic table song if you haven't heard that. And there is also me singing the elements on Channel 4 News because I just have to prove that it really did happen.
Please review us on iTunes. It really makes a difference. And please do call it the mold method. That really helps me. Or just let us know what you think on social media. For example, at FOTSN on Twitter or Festival of the Spoken Nerd on Facebook and Instagram. And you can find us individually on social media too. Or if you want to go old school, just email us, podcast@festivalofthespokennerd.com.
I mean, whenever I'm chunking, I'm like, sorry, everyone, I'm just having a little moment of mold method here. Now, if you want some more free stuff other than this high-quality podcast, of course, all of our YouTube channels are linked from festivalofthespokennerd.com or, the rest of YouTube. That's free as well. You can also download all of Helen's songs for free from Bandcamp via festivalofthespokennerd.com/shop or just keep listening to this podcast.
Yes, because I have a song at the end. It is a pretty special one. It's a version of Tom Lehrer's Elements song, which I recorded with a full brass band. I did it to celebrate 150 years since Mendeleev came up with the periodic table. Huge thanks to the Royal Society of Chemistry and Ben Valsler, who made all of this happen. And there's Water Beach Brass as well. They're the band and their conductor, Andrew Kershaw. were fantastic. The original YouTube video featuring comedians and scientists from all over the world is in the show notes, but they've also very kindly let us put the audio at the end of this podcast. So just keep listening after the credits and you will hear the elements with some added oompa.
All right, that's it.
Bye-bye.
Bye. A podcast of Unnecessary Detail is made by Festival of the Spoken Nerd. That's Helen Arney, Steve Mould, and this guy, Matt Parker. The music you're listening to is by Howard Carter. It's pretty good. All our design is by Adam Robinson, and the producer who produces this production is John Harvey. Thanks to you for listening.
Antimony, arsenic, aluminum, selenium, and hydrogen, and oxygen, and nitrogen, and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, and protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromine, lithium, beryllium, and barium. There's holmium, and helium, and hafnium, and erbium, and phosphorus, and francium, and fluorine, and terbium, and manganese, and mercury, molybdenum, magnesium, dysprosium, and scandium, and cerium, and cesium, and lead, praseodymium, and platinum, plutonium, palladium, promethium, potassium, polonium, and tantalum, technetium, titanium, tellurium, and cadmium, and calcium, and chromium, and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, radon, xenon, zinc, and rhodium, and chlorine, carbon, copper, tungsten, tin, and sodium. But now we've got lawrencium, meitnerium, darmstadtium, seaborgium, brunchenium, and dubnium, fluorovium, and borium, copernicium, livermorium, and hassium, rutherfordium, oganesson, and tennessine, muscovium, nihonium. Of course, more elements of the periodic table may yet be discovered, or more accurately synthesized for a fraction of a second in a laboratory. Don't worry, I've got that covered. I'd like to add those elements which one day may be discovered. But it took so long to learn this song, I really can't be bothered.